optimize z is equal to x1 square plus x2 square plus x3 square. We see that we okay. x1 square plus x2 square plus x3 square, and subject to constraints are x1 plus x2 plus 3x3 is equal to 2, and 5x1 plus 2x2 5x1 sorry, this is the third equation. Second equation is x1 plus x2 plus 3x3 equal to 2. Second equation, 5x1, right, 5x1 plus 2x2 plus x3 is equal to 5. There are three decision variables, x1, x2, x3 greater than or equal to 0. So we know that when we are going to solve the equality problem, that means which is solved by Lagrange multiplier method. In Lagrange multiplier method, we make Lagrange function by using the multipliers. So there are two equality constraints, so we use the two multipliers. So the objective function we write as the objective function as well as the constraints all are differentiable with respect to all three variables, with respect to x1, x2 and x3. So the Lagrange function, we make Lagrange function L is L of x lambda, this equal to objective function x1 square plus x2 square plus x3 square minus first multiplier lambda 1 and first constraint x1 plus x2 plus 3x3 minus 2 minus lambda 2 second constraint 5x1 plus 2x2 minus x3 minus 5. So this is the second constraint. So here we say that we write lambda equal to lambda 1 and lambda 2 be the Lagrange multiplier, and here we use x means decision variable x1, x2 and x3. So now we calculate the necessary condition. This is the equation number 1. We give the equation number 1. Equation number 1. So the necessary conditions, you noted this. The necessary condition noted. Necessary condition. So we differentiate for the maxima or minima. We differentiate equation 1 with respect to decision variable x1. So del L upon del x1 gives us 2x1 minus lambda 1 minus 5 lambda 2 and put equal to 0. This is the equation number 2. And again differentiate Lagrange function L with respect to second decision variable. So we see that 2x2 minus lambda 2 1 and minus 2 lambda 2 minus lambda 2 is equal to 0. This is the equation number 3. And del L upon del x3, del L upon del x3. So third 2x3 minus 3 lambda 1 minus plus lambda 2 minus this equation is plus third one is plus, this is a plus sign, so this is also plus. Lambda 2 is equal to 0, that means plus minus, this one is minus lambda 2 equal to 0. This is the equation number 4. We differentiate L with respect to multipliers lambda 1. So when we differentiate with respect to L1, so gives us minus x1 plus x2 plus 3x3 minus 2 is equal to 0. This is the equation number 4. And we differentiate with respect to lambda 2. Lambda 2, so second equation is minus 5x1 plus 2x2. So minus 5x1 plus 2x2 plus x3 minus 5. Minus 5 is equal to 0. So this is the equation number 5 and this is the equation number 6. So 5 and 6. So we have 5 equations. So I have to solve all 5 equations to obtain the value of x1, x2, x3. That means stationary values x1, x2, x3 and lambda 1 and lambda 2. So from these two equations, we know that when we put equal to 0, that means x1 plus x2 plus 3x3 equal to 2 and 5x1 plus. So we solve equations 2 and 3. Solving, we write as 2, 3, 4, 5 and 6. We get, so 2, 3, 4, 5 and 6 we get. So that means 2x1 now from 2, 3 and or you can obtain the value of x1, x2, x3. That means in from 2, 3 and 4. So what is the value of x1? So here we write as from equation number 2, 2x1 equal to lambda 1 plus 5 lambda 2. Lambda 1 plus 5 lambda 2. That means x1 gives us lambda 1 plus 5 lambda 2 upon 2. 5 lambda 2 upon 2. From equation number 3, we would obtain the value of x2. So we write as 2x2 equal to lambda 1 plus 2 lambda 2. Lambda 1 plus 2 lambda 2. We got this result, that means lambda 1 plus 2 lambda 2 upon 2. And from third equation, but the fourth equation, so we see that this is 3 lambda 1 plus lambda 2 and obtain the value of x3. This is 3 lambda 1 plus lambda 2 upon 2. So these value we can put in equation number 5. Put in 5. So when we put these values in 5, so we got, so we write as lambda 1. 5 is x1 plus x2. So you can write as equation 5. x1 plus x2 plus 3x3 is equal to 2. So we put the value of x1. So lambda 1 plus 5 lambda 2 upon 2 plus lambda 1 plus 2 lambda 2 upon 2 plus 3 into 3 lambda 1 plus lambda 2 upon 2 is equal to 2. So we see that when we take the LCM and solve this, so this gives us lambda 1. So how many lambda 1? 1 lambda 1, because LCM are same. So we put the LCM in RHS part. So lambda 1 plus lambda 1, 2 lambda 1 plus 9 lambda 1. 9 or 2, 11 lambda 1. 11 lambda 1 plus 5 lambda 2 plus 2. 7 lambda 2, 7 or plus 3. 10 lambda 2 is equal to 4. So this is the next equation. We say that the equation number 7. And similarly, we proceed put the values of x1, x2, x3 in next equation. So we obtain next equation means equation number 6. Putting the value of x1, x2, x3 in 6 also. So when we put in 6, so 6 5x1 plus 2x2 plus x3. 5x1 plus 2x2 plus x3 is equal to 5. x3 is equal to 5. So we put the value of x1. So this is the value of x1. We write as lambda 1 plus 5 lambda 2 upon 2 and plus 2 lambda 1 plus 2 lambda 2 upon 2 and plus this 3 lambda 1 plus lambda 2 upon 2 is equal to 5. So again we see that the LCM are same. So we write as 5 lambda 1 plus 2 lambda 1, 7 lambda 1 plus 3 lambda 1, 7 or 3, 10 lambda 1. So this is the 10 lambda 1 and 5, 5, they are 25, 25 or 4, 29, 29 plus 10, 1, 30. So 30 lambda 2 is equal to 2, 5 is 10. So we divide it by 10. So we get lambda 1 plus 3 lambda 2 is equal to 1. So this is the equation number 8. So we solve equation 7 and 8. Solve 7 and 8. So when we solve 7 and 8, so we get this means 3 lambda 2 equal to 1 and 7 is 11 lambda 1 plus 10 lambda 2 is equal to 4. So we multiply this equation by 10 and on subtracting. So when we subtract, so sorry 11, multiply by 11. So this cancel. So 11 3 is 33. 33 minus 10. So means 23. 23 lambda 2. 23 lambda 2 equal to 11. 11 minus 4. 11 minus 4 is 7. So lambda 2 is equal to 7 upon 23. Lambda 2 gives us 7 upon 23. 33 minus 10, 23, 23 or 11 minus 4, 7. So this is the value of lambda 2 and we put the value of lambda 2 in 1. So we find out the lambda 1. So lambda 1 plus, when we put the value of lambda 2 here, so 7 3 are 21. 21 upon 23 is equal to 1. So lambda 1 gives us 1 minus 21 upon 23. So 2 upon 23. 23 minus 2. So lambda 1 is 2 upon 23. 2 upon 23. Lambda 1, 2 upon 23. So when we get the value of lambda 1 and lambda 2, now we find out the value of x1, x2, x3. So you can put the value of lambda 1, lambda 2 in here. So to calculate the value of x1, x2, x3. So now x1 equal to lambda 1 plus 5 lambda 2 upon 2. x1 equal to lambda 1 plus x1 equal to lambda 1 plus 5 lambda 2 upon 2. So this equal to lambda 1. What is the lambda 1? Lambda 1 is 7 upon 23. So 7 upon 23 plus 5 2s are 10. Sorry, lambda 1 is 2 upon 23. Okay. Lambda 1. Lambda 1 is 2 upon 23 and lambda 2 is 7 upon 23. So 7 5 ja 35, 35 upon 23 upon 2. So this means 23 as LCM 37, 37 upon 46. 23 2 ja 46. So this is the value of x1, and for x2 lambda 1 plus 2 lambda 2 upon 2. Lambda 1 plus 2 lambda 2 upon 2. So we see that lambda 1 is 2 upon 23 plus 2, 2 7 ja 14, 14 upon 23 upon 2. So gives us 16 upon 46. So 8 upon 23. 8 upon 23, and the value of x3 equal to, you obtained as x3 3 lambda 1 plus lambda 2 upon 2. 3 lambda 1 plus lambda 2 upon 2. So 3 lambda 1, 3 lambda 1 is 2, so 3 2 just 6. 6 upon 23 plus 7 upon 23 upon 2. So 6 7 13. So 13 upon 46. These are the value of x1 x2. So we all determine all the values, stationary values. That means we write in the form x1 x2 x3. So this is 37 upon 46. 37 upon 46 upon 23 and 13 upon 46. So these are the stationary values. Corresponding, we make the order Hessian matrix. So we construct, that means for finding the solution, we determine whether the solution point is maxima or minima. Solution point is maxima or minima. So all you noted this, that means we calculate, first we make Lagrange function, then we write all 5 equations by differentiating x1 x2 x3 and lambda 1 lambda 2. Now our purpose is that to solve these equations, that is to obtain the value of x1 x2 x3 and lambda 1 lambda 2. So we think about how to solve these equations. So we see that from 1 2 3 and 4 we obtain the value of x1 x2 x3 and put in 4 and 5 and 6. So we put these value in 5 and 6, and after putting this value we obtain the value of lambda 1 and lambda 2. So these two equations we obtain, and we obtain the value of lambda 1 lambda 2 corresponding. After obtaining the value of lambda 1 lambda 2, we obtain the value of x1 x2 and x3. So these are the stationary values of finding the solution point. That means this is known as a stationary point, is for maxima or minima. So we construct bordered Hessian matrix. Bordered Hessian matrix. So you know that we take the name of bordered Hessian matrix. So that means in bordered Hessian matrix, the order of null matrix. What is the order of null matrix? So MCQ type question can be asked in this form. So in bordered Hessian matrix, the order of null matrix. That means any border Hessian matrix are given in the order of m plus n by m plus n. So what is the order of null matrix? What is the order of null matrix? What is the order of P? What is the order of Q? And P transpose. So you have to remember all these things. So that means border Hessian matrix we denote it as HB. HB we write as null matrix, and augmented by P matrix, and transpose of P matrix and Q matrix, and we take the order of m plus n by m plus n, m plus n by m plus n. This is plus sign. So m plus 1 by m plus n by m plus n order. So here we see that the P matrix P, how to construct matrix P and matrix O, that means number of variable, number of constraints on the basis of this. So we have three variables x1, x2, x3. We construct the matrix. So that means we write as m plus n by m plus. That means this Q matrix of order n by n and this P matrix of order m by n or m by m null matrix. So you know that I have already mentioned null matrix is of order of m by m. Remember this, null matrix of order m by m, this P matrix of order m by n, and this P transpose of n by m, and the matrix of Q of order n by n. So when we construct a border Hessian matrix, so we write directly, or you can differentiate HB. HB here M. M is number of decision variables. There are two decision variables. So you make a null matrix of order 2 by 2. Null matrix of order 2 by 2. And P, we differentiate H1 and H2 with respect to X1, X2, X3. So with respect to X1, X2, X3, that means when you are going to write a matrix P, so first row H1, that means decision variable subject to constraint, first subject to constraint, we write as H1 equal to, so H1 differentiate with respect to X1, with respect to X2, with respect to X3. So I have already written in previous lectures, so you have to remember these. So P, so that means we differentiate this decision variable, that means we write as Hx, so you remember this. So h1x, so h1x equal to x1 plus x2 minus 3x plus 3x3 minus 2 equal to 0, and h2x 5x1 plus 2x2 plus x3 minus 5 is equal to 0. Minus 5 is equal to 0. So these are h1x and h2x. So we differentiate h1x with respect to x1, x2, x3. So with respect to x1, h1 upon x1, del x1, del h1 upon del x1, 1, del h1 upon del x2, 1, del h1 upon del x3 equal to 3. So 1, 1, 3. So first row elements are 1, 1 and 3. This is del h upon del x1, del h upon del x2, del h1 upon del x3. Remember, we write in this form del h1 upon del x1, del h1 upon del x2, and del h1 upon del x3. And the second equation, del h2 upon del x1, del h2 upon del x2, del h2 upon del x3. So again, x2 with respect to x1, x2, x3. So 5 to 1, 5 to 1, 5 to 1. So this is the matrix P. So we mention here 1, 1, 3, 5, 2, 1, and here 1, 1, 3, 5, 2, and 1. Corresponding, we differentiate Q. That means Q for second order. Second order del square L upon del x1 square. Del square L upon del x1 square. So del square L upon del x1 square. So again we differentiate with respect to x1, so gives us 2. Gives us 2, and del square L upon del x1 del x2, so there is no x2 term, so differentiation is 0, no x3 term, differentiation is 0. So we write as 2 0 0, and second is 0 2 0, and third is 0 0 2. So directly you can write. So we also So this is the matrix of order 5 by 5. That means 2 or 3 5, 2 or 3 5. So this is the matrix of order 5 by 5. So here we know that here n equal to 3 variables, m equal to 2, m equal to 2 constraints. So we make n minus m. That means n minus m, which equal to 3 minus 2 equal to 1, and 2m plus 1. 2m plus 1 equal to 5. So this means that only one principal minor, only one principal minor of border Hessian matrix of order of 5 by 5 need to be solved. On the basis of this, need to be solved. For maximization or minimization, because we have checked the sign, because function is given only in the form of optimization, optima, not for maximization or minimization. You focus this. The function is given only optimize z. So we are doing this practice because we have to check the function is maximization or minimization. So we use the border Hessian matrix here. If a problem is given in the maximization minimization, so we solve directly. So for maximization, we have to check the sign. So what the sign? The sign minus 1 raised to the power m plus n is equal to minus 1 raised to the power n equal to negative. That means, and for minimization, the sign, you have to remember these things. We are involving what is the uh, role of negative sign and positive sign. So you know that when we solve the determinant of the border Hessian matrix, so the determinant of the border Hessian matrix give the negative value. That means we say that the function is maximization, and for minimization we have used the sign in the form of minus 1 raised to the power m. Minus 1 raised to the power m. So we write as minus 1 raised to the power m. M equal to 2. So m equal to 2. This means positive. So when we obtain the border Hessian matrix, that means determinant of the border Hessian matrix in the negative form, that means negative. So we say that the function is maximization, and for positive we say that the minimization. Okay. So now our focus to solve the determinant of the border Hessian matrix. So how to solve the determinant of border Hessian matrix of order 5 by 5? So in intermediate or relation first year, we have to solve the determinants of order 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so on. So you need to solve these determinants. Here we have a matrix of order 5 by 5. So determinant of 5 by 5, how to solve determinant of 5 by 5. So there are two ways to solve such type of matrices. So way one is that means we convert it into 4 by 4, then we convert into 3 by 3. So when we use this practice, that means we have minimized chance to mistakes. That means for the mainly concerned with the sign, because we use the plus minus sign in the determinants. So you have to focus that, which means plus minus plus minus plus minus plus minus plus minus and plus minus plus minus plus and minus plus minus plus minus and plus minus plus minus plus. So because we use 5 by 5 matrix, for when we use 3 by 3 matrix, so we have the sign plus minus plus. minus plus minus and plus minus plus. Okay, Dipanshi? Yes. So you do practice how to solve 5 by 5 matrix and 4 by 4 matrix. So now we focusing on solving the matrix of order 5 by 5. This is the border Hessian matrix. So we write this as, so we solve the determinant of this matrix. So that means we write as 0 0 1 1 3 5 3 1. So we write in this first step 0 0 0 0 1 1 3 and here 1 1 3 and 5 2 1 5 2 1 5 2 1 5 2 1 and this is 2 0 0 2 0 0 0 2 0 and 0 0 2. So you know that we have the formula for 3 by 3 determinant. That means we solve for first variable, then corresponding we write for these all variable. That means, so here we see that the two terms, that means first two first two places both are 0 0. That means determinant of that are 0. So we start with this 1. In first row we see that in both places two numbers are 0 0. Then that means determinant is 0 to this. So we write for this 1. So that means you can use for this concept the 0, that means plus we use plus, that means second is we minus and 0 and write determinant, and third one is plus, that means third one means this third element. So third one is plus 1. So plus 1, for this plus 1 what we do? We do, that means we don't use the column, this column and first row. So we write the remaining elements. So you write the remaining elements means 0 0 2 1 and 1 5 0 0 1 2 2 0 and 3 1 0 2. Okay, this is for this one, and for next is minus, because we use the this pattern, this sign pattern, plus minus plus minus plus. So for this, that means this one, for this one column, that means row element, so we do not use this column and this row. So we write as 0 0 0 0 5 1 1 5 2 0 and 1 2 0 0 and 3 1 0 2. So this is for this element, and now if we move for this element, plus minus plus, so again we use the plus sign, again we use the plus sign, and we do not use the this column and the first row. So we write a 0 0 5 2. So 0 0 5 2 0 0 5 2 1 5 2 0 1 5 2 0 1 2 0 2 1 2 0 2 and the 3 1 0 0 and 3 1 0 0. So this is 3 1 0 0. So this is the determinant, that means we solve 5 by 5 determinant, convert it into 4 by 4. You see that? So when we convert this into 4 by 4 determinant, now we can convert it into 3 by 3. We convert it into 3 by 3. So how to convert it into 3 by 3? So we can convert it into 3 by 3. That means first two values, these determinant are 0. These are 0 0. So we focus on only 3 determinant. So that means we see that for this determinant, that means we start with this determinant. So this determinant, we take this one take outside and use the bracket, use the bracket. Now when we reduce this determinant 4 by 4 into 3 by 3, so we see that first two elements are 0 0. That means obviously the determinant value of 0 0. So we can write as 0 into determinant, and minus 0 into determinant and minus and plus 2. For this 2, we write we do not use this column and this row, so we write as 150 120 312 and minus 1. For this minus 1, again we do not use this, so 150 we write as 150 122 and 310. So this is completed for first case. Okay, so for second case, that means for this determinant, we take a minus sign again, so we use minus 1 and again use the bracket, and we see that both terms, that means first two terms having 0 0, so determinant of first two terms are 0. You write as determinant 0 minus 0 plus third term is 5, so we solve the determinant for 5. So for 5, that may be so 150 120 312 120 or 312 and minus 150 120 312 and this one that is 152 120 152 152 120 310 310. So this is the second determinant, this one. And now for third determinant is plus 3. So use this plus 3. So plus 3, second two terms are 0 0, so that means two determinant are 0. Now plus minus plus the 5. For 5, write as 150 122 150 122 and 310 minus last element is 2. So what is the value of this? So 152 120 1 120 152 120 and 310. So now solve these determinants and get the answer. So when we solve the first determinant, that is this one, for 1, we use the bracket again. So when you solve this determinant, so that means plus 2 into, for this 1, 2 2 is 4, 4 minus 0, so 4 minus 0 means gives us minus for this 5, so 1 2 is 2, 2 minus 0, so 2 minus 0, 5 2 is 10, and for 0, so this is a minus 6. This is a minus 6 for this determinant, that means we have minus sign, and for minus sign, and we solve this determinant for 1, this one, so 2 0 minus 2, so this gives us minus 2. For minus 5, we see that, so 0 6, minus 6 and minus 5, minus 6 minus 5 minus 30, that is plus 30, so this is 28, and for this is for the first determinant, and minus 1 for the second, this one. So for 2 2 is 4, so 4 minus 5, we take 5, or 2 2 0, so 5 2 is 10, so minus 10, so this means minus 6, so minus 1, so this for this one 0 0, so this one is 0, first is 0, and for 5 0 0, so second one also 0, this 5 0 and 0, and for third is 2, that means plus 2, so 1 minus 6, so 1 minus 6 minus 5 2 is a minus 10, so this one, and solve last one 3 3, both are 0. That means for this 5, what is the value of this? So for 1, 0, 2, that means minus 2, and for 5, 0, and 0 or 2, 3 is 6. 0, 2, 3 is 6, minus का 6 and minus का 5, plus का 30, so 28. So this one is 28. 28 and minus 2. So for minus 2, that means this one. So for 1, 0, and for 5, 0, 0, for 2, 1, 1 minus 6, so minus 5 to the 10. So you write, that means this is equal to 6 to the 12. 12, 12 minus 28. Minus 28, that means minus 40. And 6, 5 is 30. Minus 30, minus 30 plus 10. Minus 20 or plus 20. And 140, 28 5 ja 140, 140 minus minus plus 20, 160, 160 or 3 ja 480, 3 ja 480. So this gives the positive, that means 460 means positive. Positive means minimum. We write the symbol on the basis of symbol, that's give the positive, that means minimization of the objective function. So the value of the determinant, is positive. So the above solution minimize the objective function. Minimize the objective function. Or you can calculate the value of z minimum by putting the value of x1 square and x2 square plus x2 square plus x3 square. This is our objective function. You put the value of x1, x2 and x3. So the value is 0.487. So we have the value of x1. X1 is 37 upon 46. 37 upon 46 to the square, and x2 having 8 upon 23, and x3 13 upon 46.